Have you ever built a search system, you get a ton of results back, but the one you really need is, like, buried on the second page? We've all been there. Well, today we're going to talk about the fix for that, a really powerful technique called re-ranking. It's pretty much the secret sauce for getting the absolute best answers right up to the top where they belong.
So what's the big idea here? Well, it all boils down to this simple, powerful promise. See, re-ranking isn't about finding more stuff. It's about taking the stuff you've already found and just, well, making it better. Use a smarter, more powerful model to give those top results one last look over.
But, why do we even need an extra step? That's a fair question. It really all starts with this classic problem in, well, basically any kind of search. You're always fighting this battle between being fast and being accurate.
I mean, seriously, think about it. Your system has to sift through maybe millions of documents in milliseconds. So of course the number one priority has to be speed, right? But does that speed ever guarantee that the first result is actually the best answer? Let's be honest, probably not.
Right, so that first search pass, that's what we call retrieval. And its main job is to be a super fast filter. It casts this huge wide net to pull in a big list of maybes, documents that are potentially relevant. It's all about speed, not about some deep, nuanced understanding of your query.
And this is where re-ranking just comes in so elegantly. It's a two-step solution. Instead of trying to make one single step do everything perfectly, which is kind of impossible, we split the problem in two. First, we retrieve, and then we refine.
Okay, so what is re-ranking really? Here it is. Once you've got that big initial list of candidates, re-ranking takes just the top few, maybe the top 10 or top 50, and brings in the heavy machinery. It uses a much more powerful and, more computationally expensive model to reorder them based on what's truly relevant.
And you can really think of the workflow just like this. Step 1 is all about speed and scale. Just getting that big list of potential hits as fast as possible. Then step 2 is all about precision. It's taking a second, much closer look at just the most promising candidates to find the absolute best one.
So what's actually powering these two different steps? Well, it comes down to two different kinds of models, and each one is designed for a very specific job. Let's pop the hood and take a look.
So for that first super fast retrieval stage, we use something called a bi-encoder. You can think of it like a librarian who's already read every single book and has assigned each one a number. So when you ask a question, the librarian just finds the books with the closest numbers. It's incredibly fast because all the hard work was done up front. But for the re-ranking step, we bring in the specialist, the cross-encoder. Now, using our library analogy, this is like having an expert who takes your question and actually reads the top few books side by side. They can understand all the nuance and the context in a way that just comparing numbers never could. And that gives you a much, much more accurate score for relevance.
So here's the bottom line. Bi-encoders are your sprinters. They're incredibly fast, but maybe a little less accurate. They're perfect for that first pass. Cross-encoders, on the other hand, they're more like your marathon runners. A bit slower to get going for sure, but they have that deep stamina for incredible accuracy, making them absolutely perfect for that final critical re-ranking step.
And this is where you can really see that trade-off we're talking about. The bi-encoder, it gives you pretty good results almost instantly. But the cross-encoder, while it takes a little more time, the accuracy, the actual quality of that final list, it just goes way, way up. And that is the heart of the whole re-ranking strategy.
Okay, so theory is great, but where does this actually get used? Let's talk about how this plays out in a real-world application that, honestly, a lot of us are working with right now. Retrieval Augmented Generation, or RAG. With any RAG system, the quality of the answer you get from your large language model depends entirely on the quality of the context you feed it. Garbage in, garbage out. By using a re-ranker, you make sure that the documents you're feeding to that LLM are the absolute most relevant ones you could find, and that directly leads to better, more factual, and way more helpful answers. It's a game changer. So, at the end of the day, what's the final verdict here? What's the one thing you should really take away from all this?
Honestly, it really just boils down to this. This captures the whole value proposition perfectly. You are adding a small, pretty manageable step to your whole process for a massive, truly game-changing improvement in the quality of your results.
And yeah, okay, a cross-encoder is slower, but remember, you're only using it on a tiny fraction of your documents, just the top candidates from the first step, so the overall impact on your system's speed is actually minimal.
It is such a small price to pay to make sure your user gets the best possible answer, right at the top of the list.
And that really just leaves us with one last thought. Whether you're building a search engine or a recommendation system or a RAG-powered chatbot, just ask yourself, where could a massive boost in relevance completely transform your user's experience? I really hope this explainer gave you some ideas on how to do just that.